All right, this lesson is on solving a system using the elimination method. We've learned two other methods already. The graphing method, where you graph two equations either by hand or using the graphing calculator and see if the points or the lines intersect at a point. We've also used substitution method to solve for the system. Most students tend to like this method as their favorite, using elimination method. So you can go ahead and pause and read this paragraph if you want. But the big thing I want you to know is we're going to want to make sure you add the equations together. Okay, let's go ahead to our first example. So what we have is a linear system, and we want to find out what the solution is. So when you do these, you want to make sure that the system is set up as such, where you have your x, your y, and then your constant off to the right. And what we're going to do is we're going to go ahead and add these two equations together. And we're going to hope that one of the variables cancels out. So 4 minus 12x is negative 8x. Then when I add positive 7y, negative 7y, they eliminate. So that's awesome. So we wanted to eliminate. And then we add the right side of the equation. So negative 25 plus 19 gives you negative 6. So we've eliminated the y variable. Now we just go ahead and solve for x. So we divide both sides by negative 8. The negative 8's cancel. And then we reduce that fraction. Negative divided by negative is a positive. And then 6 divided by 8 reduces by 2 to 3/4. So that's the first step, is to find one of the variables. Now you have a choice. You can substitute this x equaling 3/4 in either the top equation or the bottom equation. It doesn't matter. And you're trying to find out what the y coordinate is. So I'm going to go ahead and substitute into the top equation. So 4x plus 7y equals negative 25. And we take this 3/4 and substitute it in for x. And then we'll just be left with the y coordinate, or the y value. So 4, replace the x with 3/4. And now the 4's cancel to 1. So 3 plus 7y equals negative 25. We subtract 3 from both sides. Negative 25 minus 3, negative 28. Divide both sides by 7, and we get y to be negative 4. We do want you to always write the solution as an ordered pair. So it's your x, comma, your y. Example 2 is a little bit more challenging because if we look at the setup and we try to add the equations together, neither the x or the y eliminate. So now we need to do some multiplying. We need to adjust one or both of the equations by multiplication. So what we're going to do is we're going to multiply this top equation by 5. And then this bottom equation by 3. And the reason why is we want to eliminate that y. So let's see what happens. So the top equation, we multiply all of the terms by 5. So we get 5 times 5x is 25x. 5 times negative 3, negative 15y. 5 times 42, 210. Then we multiply all three terms in the second equation by 3. So 3 times 8x, 24x. 3 times 5, 15y. And then 3 times 28, 84. Now we add the two equations together. So we get 49x, and then this is what we wanted to have happen. When we add a negative 15y and a positive 15y, it eliminates. And then we add 210 plus 84 is 294. So we've eliminated the y, we solve for x. So we divide both sides by 49, and x equals 6. Now you get to choose. Either we can substitute into the top equation or the bottom equation. It doesn't matter to find that y. So I'm just going to take that top equation and substitute. So that 6 goes right in for that x. So replace the x with 6. And we're going to solve for y. So 5 times 6 is 30 minus 3y equals 42. Then we subtract 30 from both sides. Reduce 42 minus 30 is 12. And then divide both sides by negative 3. And y equals negative 4. So you want to write that as an ordered pair. X, comma, y. In that lesson 3.1, we've learned about infinite many solutions or no solutions. So what's going to come next is sometimes when we're solving these systems by elimination, if you get 0 equaling 0, what that's going to represent is infinitely many solutions. They are essentially the same line. If we get something like the variables are still there, but we only are gone, we get some numbers, what this is telling us is that these are parallel lines or no solution. And what we've seen in the previous couple examples, this example here and this example here, those are where the two lines intersect. So they're one solution. All right, let's go ahead and do an example. So classify the system and identify the number of solutions. So we want to use our elimination method again. So if we look at the two equations and we add them together right now, they're not going to eliminate. So I'm going to multiply this bottom equation by negative 8. Because I have a positive 8y, I'm going to multiply it by negative 8 so that when I add them, the y's cancel. So we have 56x plus 8y equals negative 32. So there's that top equation. Then we multiply the bottom equation by negative 8. So all of these terms get multiplied by negative 8. So we get negative 56x, negative 8y equals positive 32. Now let's add them together. So when we add, this term becomes 0, this term becomes 0, this term becomes 0. So 0 equals 0. So what does that mean for our system? So if we go back up here, when we get 0 equaling 0, it's telling us that these are the same line. They're right on top of each other. They're infinitely many solutions. Coinciding lines. So there are infinitely many solutions. All right, next example. If we add these two equations together right now, they're not going to eliminate. So I look at this 3y right here. I'm going to multiply this term by negative 3, and then they're going to eliminate. So I have to do that to the entire equation. So multiply this entire equation by negative 3. So we'll leave the top equation alone. We're going to multiply the bottom equation, all of the terms, by negative 3. And we get negative 6x minus 3y equals 18. Now let's go ahead and add. So when we add, these two terms cancel out. These two terms cancel out, equals 6. So 0 equals 6. So when we go back up to our notes, when we have a number on the left and a number on the right, that's telling us that these are two parallel lines. They're not going to intersect. They're going to have the same slope but different y-intercepts. So how we classify this is there is no solution. The reason why is they are parallel lines.